long-standing colleague of mine now. He's been a fantastic mentor over a number of years. Bruce has a long history in working in biodiversity restoration in New Zealand. He hails from the Taranaki region, but he currently obviously lives and works in Hamilton. And so without further ado, I'm going to hand straight over to Bruce, and take it away, Bruce. Thanks.
So I'm just going to check the volume. Is that clear enough? Can you all hear me? Excellent. And the video camera has started. Kerry's pressed the record button. And I believe everything is going to work. It is my privilege to be here this evening. And I like the look of the size of the audience, because I'll come a bit closer and we can actually interact a bit more. This is my passion, to be honest. I've been working in ecological restoration for quite a long time. Toku monga ko Taranaki, toku awa ko Manganui, as Andrea said. I was raised on a farm in Taranaki, and I learnt most of what I know about nature as a young child and turned that into a career that it's just been a fantastic opportunity for me to do the thing I like doing throughout my career. And what I wanted to do tonight was tell you about my most recent interest, because I've been in the game for quite a while. Some of you will know just by looking at me. I wouldn't quite say I'm over the hill yet. I'm still heading into the home straight, actually. I'm still picking up momentum. And I was inspired as a child by Indigenous nature, starting with birds at the age of about 8. And I progressively ran out of birds to identify, so then I moved on to plants. And so I am a plant ecologist by training. Forgive my bias, but I will try to take an ecosystem approach. So as the title of my talk says, I'm interested in bringing Indigenous nature back into towns and cities in New Zealand. Urban ecological restoration is my passion in more recent years, because as I've got less mobile and slowed down, I've started taking notice of what's in my own backyard. I started in the wildlands, up in the mountains, in the wild country, if you like, and I've progressively moved into the urban environment. And I've tried to apply the principles that I've learnt in the wildlands to the difficult job of restoring and reconstructing Indigenous nature in towns and cities. We all know the world is becoming increasingly urbanised. So about 50% of us, over 50% of us live in cities already around the world, and the projection for 2050 is 64%. That projection actually keeps changing every time I look on the website. It goes up slightly, actually. So it's important to recognise that cities are one of the big drivers of resource use and the condition of the environment. Because the more of us there are, and the more focused we are on an unsustainable life in cities, the more resource we consume, and the impact we have on the environment is way broader than the footprint of our city. The concept of ecological footprint is very powerful, I believe. The data that's shown there on the slide, I think, really shows the extent to which urban areas have an impact on their surrounding land. The statistics you can read for yourself. I think the third bullet is particularly important, that the average world citizen's eco-footprint of 2.7 hectares, while there's probably only around 2.1 hectare of bioproductive land and water per capita on Earth. And the saying by the famous, who knows who said these words, these famous words, Earth provides enough to satisfy every man's need, but not every man's greed. Any guesses from the audience? Mahatma Gandhi said this. Mahatma Gandhi, you knew that. Somebody over there knew that, but they just didn't say it at the time. So I sort of come from that perspective of thinking, well, okay, if cities are a problem, what if we turned that notion on its head and gave some thought to viewing cities as the opportunity, as the possibility for a solution to saving biodiversity, not just in the city, but more widely across the region and perhaps even across the nation. And the talk really is focused on concepts of nature, particularly native plants and animals, green space, and that broader notion of restoring natural capital. Perhaps just a comment about urban ecology. Why urban ecology? Compared to more traditional approaches of conservation biology or even standard ecology, urban ecology is a newer discipline. It's only really emerged in the last 20 years, and it's an interdisciplinary approach that comes to the fore in urban ecology, not just ecological scientists, but social scientists, psychologists. All those areas of expertise come together in order to understand a system which includes human beings. And above all, from my perspective, the last bullet there is particularly important, using that information to help societies with their efforts to become more sustainable. So now, just a few thoughts about our system here in Aotearoa, New Zealand. So the 20 largest urban centres in New Zealand are shown on the map there, and 87% of New Zealanders are actually urban dwellers. So we're an urban nation, although, you know, when you look at the pictures in the tourist brochures, you wouldn't think that, would you? So the thing is, you can see on the map where are these urban centres concentrated. Of course, they're all concentrated in the coastal and lowland zone, with a couple of major exceptions. Kirikiriroa, Hamilton, where I come from, is an inland city. There are not many inland cities. And of course, Rotorua is another one, more inland, and Taupo another. But mostly they're in the coastal and lowland zone, and that is where the impact on our biodiversity has been greatest, where these large towns and cities are located. We use the term city in New Zealand possibly a bit liberally. Internationally, we've really only got one big city, right, up in Auckland, and the rest of us are large towns, possibly small cities, and also because our total population is so low and our population densities are so low, we don't really compare too well with many global cities. Small urban centres and the mean footprint, the mean urban core for New Zealand towns and cities, the top 20 that is just over 4,000 hectares. The statistic though I want to start my discussion with tonight is the last bullet on the slide there. How much have we left in our urban centres of the Indigenous? What have we left as we've developed new cities? In a very short time, of course. Only really in the last 120 years has most of this urban development occurred. So notice the figures, less than 1 to 8.9% Indigenous cover remaining in the built-up part of urban centres in Aotearoa, New Zealand. There are statistics from the world which show that those figures are extremely low. Some of the newly developed eco-cities in South America have 30 to 40% of the remaining environment still in their Indigenous cover. Cities like Perth have at least 20% within the city of the original vegetation tucked away in some places. So internationally, we're not doing too well in terms of retaining Indigenous habitat within urban centres. In 2007, I tried to, get a better understanding of how this worked in our country by doing some work using a GIS model and thinking about how the biodiversity or the Indigenous cover was distributed across the urban-rural interface. And these are the graphs that arose from that study in 2007. Focus on the axis here, which shows the distance from the centre of the city, from 0 kilometres out to 20. And notice here again the figure for the percentage of native cover. And I want you to particularly think about this level here, the 10% level. 10%, because I'm going to come to that again shortly. So these are the different curve types for New Zealand cities. And of course, Kirikiriroa Hamilton fits into the curve A type, the Hamilton syndrome, you could call it if you like, which shows that it starts with next to nothing and ends up with a little bit more than nothing as you move along that gradient. And of course, Christchurch City fits within curve A as well, and I'll come back to that a bit later. The two other major types here relate to cities like Nelson and Dunedin, where they start quite low, but they very quickly move into zones where there are significant amounts of Indigenous cover. And usually that's related to terrain, particularly to the landscape itself, the topography of the city. And anybody who goes to Wellington on a regular basis will know, as you fly in, right, and you get down onto those plains where the city is focused and concentrated, surrounded by the hill country, and up on that hill country is where the town belt is, which contains significant amounts of Indigenous habitat. Same for Dunedin. But just like the other curves, in some cases, there's that as you move into the rural zone, you start to lose cover again. So I've sort of used this as if you like, as a model to try and think about what we might do to fix the situation. And I've focused in recent times on the 10% figure because I think this is a particularly significant one. Ecologists in particular have done a lot of work on what the significance of the 10% figure is. And here we go. So why 10%? Mainly because if you do not retain on a landscape a minimum of 10% Indigenous cover, you have significant loss, and that essentially leads to extinction. So the three bits of evidence that are presented on the slide here are based on the work of Finnish ecologists, Hansky. I'll show you a graph shortly on this. Also some recent New Zealand work by Ruffle and Didham, which shows that it's really important not to drop below figures of 5 to 10%. And if you do something to enhance areas that are that low in cover, you will get very large benefits from doing that work. And I also wanted to draw your attention to the current draft National Policy Statement on Indigenous Biodiversity. Here, the draft policy 19. So this policy is currently being promulgated by the new government, and the expectation is that it should be in legislation by the end of this calendar year. And policy 19, based on some of these ideas, is suggesting that restoring Indigenous biodiversity in depleted environments, a target for Indigenous cover in urban areas and peri-urban areas must be at least 10%. The question is, will this survive in the draft to the promulgation stage? I'm hoping that some people tonight might be convinced, and they might send a letter to their local MP and say this is really worth doing, because unless we have a target like this, the danger is we will never get close to restoring enough habitat on our landscapes to prevent significant ongoing extinctions. So here we are. This is the Finnish ecological work, and you can see the loss of species at the 10% line here. This is the 10% fraction of remaining habitat. When habitat is reduced and fragmented, there is a dramatic drop in the numbers of species remaining in the system, and this is usually referred to as the extinction threshold. Similarly, when we're up in the zones up in here, people talk often about what's called the percolation threshold. This is the threshold at which the movement of propagules of plants, for example, or the mobile species like birds and bats, and can effectively move across landscapes and retain the metapopulation over a broad regional scale. So the interplay between those two thresholds can be very significant for the survival and retention of Indigenous flora and fauna. Now, not to forget, because I do understand the significance of the importance of predation in this equation, I've just put this slide in there to remind me that yes, we need to retain and grow and expand habitat, but at the same time, particularly where we're wishing to retain our native birds, we need to deal to predators like the ones illustrated here. As I move through my talk, I want to remind you though that it's not just about native birds, because predation on seed is another significant factor driving the current state of our ecosystems. So I've started doing most of my work in the space urban ecology in Hamilton, and I wanted to use that as a bit of a case study first. So I'm going to now move into the second part of my talk. I've given you the context for urban ecology. I'm now going to give you some ideas about what has worked in Hamilton, and then I will progressively move into the last phase of my talk on thinking about more widely across New Zealand what might be taken from the learnings in Hamilton, what is applicable, but also what may not necessarily be applicable to other urban centres in Aotearoa, New Zealand. So this is the situation that confronts us in Hamilton. The Hamilton Ecological District, with the city of Hamilton nestled here on the broad alluvial plains, bisected by the largest, longest river in the country, the Waikato River. And you can see that in terms of Indigenous biodiversity, it's pretty well a biodiversity desert. We do have some small covenants, Queen Elizabeth II covenants, 42 of them, but note the size of them. Mean size 4.4 hectare. Within the city itself, we have about 200 hectares of Indigenous cover. We'll find out soon how that arose, that figure. Across the whole of the ecological district, which just bounds the edge of this range here, the Hakarimata range, less than 2% of the original Indigenous cover remains. It's all been converted largely to pastoral agriculture, and in recent times even greatly intensified, leading to further losses of Indigenous biodiversity. So this has been the situation that's confronted me and my team in the Waikato, and this is the situation that we've been trying to rectify. In the urban system, subdivision is paramount. So the biggest problem that we have in Hamilton is that even though we've got very little biodiversity left, as subdivision proceeds, it does two very serious things. First of all, it covers over our versatile, our best producing soils, often with impervious surface, which has in its own right significant environmental impact, but it also focuses the attention of the subdivider on often getting as many sections as possible into the land of the subdivision, often at the cost of what little remains of Indigenous biodiversity. And of course, I'm going to eventually get to talk a little bit about these features in the Hamilton system, the Hamilton Gully, and the significance of them for ecological restoration. This is a view of the place where my own house is located now, and the purpose of this one is just to make the point that not only is the subdivision a problem, but the impacts of the way the remaining pieces of land are used is important. You can see the tyre dump here from the local garage, where the garage used to back the truck up to the edge of the gully and just tip the tyres into the gully, and then later, of course, we had to deal with removing the tyres in order to restore the gully. So subdivision then is an ongoing issue. However, in our small city of just over 10,000 hectares, we have scattered across it 67 key sites, we call them. These are equivalent to significant natural areas. They've been scheduled in the Hamilton District Plan. 67 of them, but notice the mean size, extremely small. So the point here is that, is this big enough to be sustainable in the longer term? And I think you know the answer to that already. This is what's been driving our approach to ecological restoration. Here are two of the most significant remaining patches. This one here, Hammond Bush, which is a little remnant of swamp forest down on the edge of the Waikato River. And this one here, Claudelands Bush in the Claudelands suburb, which is the 5.2 hectare equivalent of your Riccarton Bush. It's so similar. You need to see it and see those similarities. I must mention the two people on the slide here. My good friend Charles Doherty, and the man in front of him is Richard Loeb, the author of the book Last Child in the Woods, which is so pertinent to ecological restoration in urban settings. So we know what to do about looking after the little bits, but we have to do a lot of work just to keep them going, removing weeds and pests. The real important thing about it is that on their own, they are not really going to be sustainable. And the question is, what are we doing to buffer them? And also, what are we doing to connect them together, to expand the resource, to make it more sustainable? And the point that I'm making, of course, is that in cities like Hamilton, Napier, Hastings, Christchurch, reconstruction or retrofitting of Indigenous habitat is needed if we're going to have a sustainable resource in the longer term. And when I talk about reconstruction, I'm really talking about moving beyond notions of just revegetation, where people go out and do tree planting. I'm talking about bringing back all of the ingredients of the system. Not just birds either, not just focusing on the birds, but can we bring back all of the ingredients? Can we focus on full assemblages and species occupancy to build a habitat which has a functioning ecosystem in the longer term? For my framework, when I say my framework, I've done a lot of borrowing and begging and looking around the literature and done all sorts of things, but also because I've worked in wildland systems, and particularly in volcanic systems, where I've seen the consequences of natural destruction by eruption, landslide, flood, whatever, and learnt the principles of how nature rebuilds ecosystems, I've tried to apply those principles to the urban environment, which also has often a very difficult environment in order to reinstate both plants and animals. And in doing so, I've taken up the challenge of the British ecologist, Tony Bradshaw. He was the president of the British Ecological Society. In 1983, he suggested, this is the challenge to all ecologists, that the ultimate challenge is to reconstruct ecosystems. If you don't know how to reconstruct them, you actually don't know how they work. And so I've been prepared with my team to try and take up this challenge. So our approach really has been linking natural succession and recovery to the notion of restoration and reconstruction, using a successional framework, trying to understand the different constraints and opportunities presented by the urban environment, understand how the system works, the processes, the functioning of the system, but particularly to try and bridge ecological theory and practice. In other words, to help all of the community groups out there who are doing the hard work and try and inform that process with learning about the things, the way things really can work to your advantage. In Hamilton, we've focused largely on the gullies. So these are the little streams that feed into the Waikato River. They were formed by a process of spring sapping. Springs, that water that flows laterally because of some of the peat soils flows underground towards the Waikato River, and where the water emerges at the bank of the Waikato River, it cuts back in a process of spring sapping to produce these intricate patterns, this network of veins across the city, the Hamilton Gully. This one, Mangako Tukutuku, is named after the native tree fuchsia by the local hapu. You know, this is a traditional name for this gully, and it also gives us a clue about what our target might be when we're going for a restoration. Mostly gullies nowadays are comprised of what some researchers call novel ecosystems. Actually, I prefer the term that Colin Merck proposed for this, recombinant ecosystems, I think was the term that Colin used, because the word novel gives the wrong impression about these systems. These systems, although interesting and sometimes containing important features like Ruru will live in an old willow tree where there's enough cavity and enough perching site and what have you, are largely problematic for most of our indigenous flora and fauna. They simply do not provide the services needed to maintain the full indigenous species assemblage. Notably, they don't provide nectar for our nectar-feeding birds. They do need to keep in mind, though, that if you are converting a system like that, you might need to do it in a transitional way to look after special features as you progressively convert the system to one dominated by indigenous species. So we have targets for all of the main ecosystems in Hamilton City. This is the target ecosystem for the gully bottom. The gully bottom used to be occupied by a swamp or semi-swamp forest, and interspersed amongst that often were herbaceous wetlands as well. So our target is essentially one dominated Hakatea, Pukatea, and the native family in the myrtle family, the swamp Maori, which is an amazing ecological engineer. Here's its flower here. You see it's in the same family as Pohutakawa. And it is an ecological engineer which has pneumatophores, breathing roots that stick up out of the water, a wide-spreading root mat, and it can actually, one of the few native trees that can compete directly with bad weeds like green goddess or the arum lily. The swamp Maori gives it a run for its money. So we've been doing this for some time in Hamilton City. The oldest restorations in gully settings in Hamilton are now over 60 years. There's one site where a guy worked on it for over 60 years. These are the sorts of results. Remember that what is now in the picture was once grey willow or crack willow forest. And here we are in Mangaiti, and you can see that we've converted this to an indigenous system dominated by sedges. There are some flax in the background there, and there's a bit of a beginning of some manuka planting going on. This is the forerunner to the development of a semi-swamp or swamp forest system. Here, this one in the Onukutara, this is my own backyard where I've been turning this into a semi-swamp forest in the Onukutara Gully with the help of my wife and the whole family and anybody I can rope in on any occasion. 25 years now of restoration, and this is looking really like something like the original system. On the field trip that was held in Hamilton at the Sarah conference a couple of years back, we took people into the oldest gully restoration. We took people in there into Seeley's Gully, and we didn't tell them that it had been created by human beings, that it was, in other words, is it natural? And there was this huge debate went on the day. I've also put the slide up here to show that I'm proficient in social media, right? Instagram, Twitter, that's me, yeah, right. You can see here there was a little debate going on about the quality of this forest. And of course, at the end of the field trip, I had revealed to them all that actually this was created by human beings. And I also reminded them of the saying of the man who started the project, Elwyn Seeley, who started this project, who made the comment way back when he started, "I have every weed known to humankind, but in the end the bush prevails." Very insightful ecologist, started as an amateur, ended up knowing all about the species, the processes and the functioning of the ecosystem. So in Hamilton, we haven't been content with just doing work in Hamilton gullies. We've moved on to some other pieces of land, public land. So here we've been able to work with city councillors and convince them that public land, which is currently not being used for a specific purpose, might be useful to reintroduce indigenous species, to create new habitat. This site, Waiwhakariki, is up near the Hamilton Zoo. Very important location because the people who know all about growing on the wildlife, if you like, are sitting just across the road here, and we might want to use them soon. We haven't quite got there. This is the plan, and each of the ecosystem types is demarcated on the plan. You can see here on the ridges, Kauri Forest, Hill Slope Tawa, Kahikatea on the low-lying, poorly drained soils, Harakeke on the lake margin and so on. And the first tree in this system was planted in 2004 by the then Minister, Conservation Chris Carter. So in that time, from 2004 to 2018, we have reconstructed 36 hectares of newly growing indigenous habitat. And think about that statistic I gave you previously about the 1.1 hectare average size and the largest remnant, 5.2 hectares. See what we've done already in this short time? Some people say, oh, that's a long time, but actually in ecological time, this is an extremely short time. So 36 hectares in place. And how do we do it? This is how we do it. Community involvement. The whole project is a consortium of multiple community groups and a whole lot of important stakeholders like the regional council, the city council, the university, the polytech, the local iwi, Ngā Mana Tupu or Kirikiriroa, all based on that monitoring. So I do have a few examples that I wanted to show you for other reasons, to reinforce some of the other important concepts. So some of the research, as I said, is not just for the sake of doing research, it's directly applied to a problem. So here's the monitoring network in Waiwhakariki here, began in 2006, and you can see that all of the plots are in place, and we use this to inform success. You know, what is the survival rate of the species? Which things do best and why? And how do we adapt to the change? How do we make sure that in drought years that we don't lose too many plants? Do we use mulching? Do we not use mulching? All of this is informed by underpinning research. We also have developed a GIS planting tool. So this tool is to help with the process of ordering and, well, determining where do you get your plants, how many do you need, where do they go onto the site. So this is a GIS tool that you can feed this data in, feed the output out, and then you can go to the nursery, the EcoSource nursery, and give them the planting list for the next 2 to 3 years for different parts of the project. But we also try to marry theory and practice. We're trying to understand the behaviour and functioning of ecosystems. And this is a structural equation model. You don't have to learn it tonight. I'm not going to give you a test on it at the end of the night. But it's a structural equation model which shows the critical variables that you need to understand if you're going to be successful in these sorts of restoration plantings. So we found the key predictors, and we use as our indicators of success here one variable, tree regeneration richness, and the other one, epiphyte richness, because epiphytes in particular are a good indicator of how far the planting has progressed. How close is it getting to functioning like a natural system? And these are just some of the bits of data that underpin it, and you'll notice that also what we're focused on is thresholds. Here, the shift in humidity that occurs at about 20 years as you get control of the canopy and you maintain a stable climate which is then conducive to producing seedlings and also enhancing opportunities for colonisation of epiphytes. Looking at it across a range of variables, you can see the breakpoints here on the curves. These are all critical breakpoints, and here they go. Here is the 20-year thresholds for all of these critical variables where you can see that you're really starting to make progress with a newly developing forest. If you want to check this out, it's all published. Curie, the senior author, is back there manning the video tonight. Wallace, Lachlan and myself. And this information is used to understand how close are we getting to obtaining a functioning system like a natural ecosystem. We believe that you can manage forest ecosystems from restoration planting and cross these thresholds to create fully functioning systems. One of our biggest problems up our way is Tradescantia. How many of you have experience with Tradescantia down here? Possibly not as bad as what it is up our way. So there's a gradient in New Zealand of Tradescantia difficulty. The further north you go, the worse it gets. This is a trial where we're trying to understand how tall do you need to plant the late successional tree tawa in order for it to escape the scrambling and overwhelming of the Tradescantia. In Hamilton, the height of the sapling needs to be about 1 metre. In Northland, it needs to be 1.5 or almost 2 metres tall. Who knows what the threshold here is in Christchurch? Colin?
Probably half a metre.
Half a metre. I would have thought so.
Well, it fits your curve anyway.
Yeah, it fits the curve. But the thing I wanted to point out here is the world is changing. We designed this research to solve a current problem. And of course, what has now happened in New Zealand through the good work of Manaki Whenua Lankler research, the introduction of the beetles that eat Tradescantia. I don't have a photo to show you, but we've only recently introduced the beetles into our own gully. Don't tell people how I got them. No. How did I get them? Well, of course, I went to somewhere where they'd been introduced and then grabbed a few and brought them into the gully, and already all of the work that we've done on understanding this threshold is becoming largely redundant because they are extremely effective at defoliating Tradescantia. So it won't be long, the beetles will spread all over the place and natural regeneration will occur much more effectively than having to plant 1 metre tall saplings. I also wanted to remind myself, as much as anything, but all of you, about the significance of predation. Although I'm interested in building and restoring new habitat, I do understand the other side of the coin, which is the importance of predation. But I would say that in New Zealand at the moment, because of all of the effort focused on predator-free 2050, I think some people have forgotten about the habitat restoration side of the equation. Anyway, I'm reminding myself of the importance of predation here. This is what we had to do in Hamilton to bring tui back into our system. We built the new habitat. This was occurring as an uncontrolled experiment across the landscape. The habitat building was going on, but the birds were not arriving, or when they were arriving, they came in low numbers and did not stay long. So people in land care research, in particular John Innes, was responsible for developing what was called the Hamilton Halo Project. This involved intensive pest control in a 15-kilometre radius around the city. The red zone are the places where pulsed and intensive pest control occurred in order to knock those predator numbers down, and then this is the result. So prior to, I lived in the gully where I live now, prior to 2007, in the whole of the almost 20 years that I've lived there, I saw a single tui. And by 2007, as a result of this work, 11 sightings, 2008, 28, by 2009, 490, and the public got sick of reporting the sightings because there were so many of them. But most importantly, not only were the birds sighted, the first nest was recorded in 2007. So the birds have come back and are now reproducing in the city. So that threshold, the tui tipping point, has been crossed. But it is a combination of the result of producing new and expanded high quality habitat and the pest control. And again, a reminder of the importance of predation. This is some fancy experimentation we did trying to understand the rates of seed loss in the Hamilton system. Again, we don't need to focus too much on the detail of the graphs, but large amounts of seed are lost all of the time because of those predators. Those same predators that are killing the birds, that are eating the eggs, are also chewing and destroying the seed. And so if you focus on reducing their numbers, you can enhance the reproduction of plants as well as birds. But again, the world is shifting on. We did all of this work, and now with predator-free 2050, and the take-up in Hamilton City by community groups of predator control, all of our fancy efforts to use